Howdy, everybody. Today we are discussing the topic of neural networks, and specifically we're going to look at two here, a gated recurrent unit and a generative adversarial network. So there's all kinds of neural networks out there, many shapes and varieties and versions of these types of things. I'm just going to focus on these two. I think it's very interesting. I think you'll learn a lot. Hopefully you can stick with it to the end. There's a lot to pick up here, but the payoff is going to be huge, right? So how does this work? It's kind of like a biological organism learning how to process data, input take data from different inputs, and then pass that to the next layer of neutrons. This is how a human being or any kind of biological organism would learn, right? By repetition, by doing the same thing over and over, by seeing the same thing multiple times and associating that with a specific outcome, right? So you have the neuron layer and then three different layers. An input layer, this is the initial step. The hidden layer, this is pretty complex. It's an intermediate step of layers where the data is actually processed, and it could go forward or it could go forward and backwards multiple times until the processing is done. And then the output layer is the final result of all the computations. So what can we do with a gated recurrent unit? These are neural networks commonly used for all kinds of modeling tasks. It could be sequence prediction, sequence classification, sequence generation, okay? Generate new sequences from existing sequences. We're going to see an example of this in just a minute, how we can basically do sequence prediction with words, right? If you want to do sequence generation, you could take a bunch of words, put it into this model, and it would create brand new sentences, new paragraphs, even entire poems and volumes of books as well, right? So sequence to sequence learning, you could do temporal pattern recognition. So it's great for classification purposes as well. Feature learning, learning nuances and details about the feature that's being fed into the neural net. And then time series analysis, okay? So there's a bunch of time series libraries out there. I made a video and posted that already about time series analysis. You can use GRUs to do time series analysis as well. So in this example, we're going to take a very small body of text and feed that into the neural net. You don't have to understand all the details and all the nuances of what's going on here. It's a little bit complex, but you can take this example, copy and paste it, and run it on your Jupyter Notebook environment, and you'll get exactly the same results. And of course, this is the variable here. So you can plug anything you want into this spot right here, and it's going to learn that text no matter how big it is, no matter how complex it is, and it's going to be able to make a prediction of the next words that it sees. So it's going to see two words you can see at the beginning, and based on the learning processes and the sequence of the inputs, it's going to make a prediction of what comes next, okay? So let me go down to the important part here. Prediction. Once the model is trained, we need to make a prediction. So I have another video on this. This is the whole point of feature engineering and data science, right? You train the model, you test it, see how accurately it's performing, and then use the trained model to make predictions so you can understand what's happening next. So we have the predicted model. I'm going to go ahead and run this, Control Enter to run. And I see here the first two words is the quick. I'm sorry, the first two words, the quick, right? In quotes. I want to predict the next three words. So if we go back over here, where's the quick? You see it right about here. Okay, so there it is. The quick. Brown fox jumps, okay? So we expect three more words, brown fox jumps, because we're saying learn these different features right here. This is one feature. They're comma separated in this case. These could be columns in a data frame. This could come from a database, import into a data frame, and then each of these columns could be analyzed to see what the next sequence of words is. So we have the quick, we would expect brown fox jumps. Let's go down and see what's going on here. Okay, so it's running. We are up to epoch number, looks like high 50s, 60s, 90, 100. Okay, got it. The quick brown fox jumps. So that's exactly what we'd expect from this GRU, right? It learned the sequence of words and it made the next prediction. Let me go back and find another example. Not from there, but from here. We need, okay, let's do this. We need to do grocery shopping. We would expect 4 more words. Okay, let me try this. We need, I'll retrain the model again, and then make the prediction. Actually, I don't have to retrain. I could just make the prediction. The model's already learned, right? So predict. Oh, I know. Yeah, I have to put this in this cell, right? Because this is not spider. I spent a lot of time in spider. I forgot for a second. Can't do that here. Okay. Control Enter. We need to do grocery. Okay, so that's exactly what we would expect. We need to do grocery. We need 3 words after this, and it's making that prediction. If I rerun this, we need to do grocery shopping. Okay, perfect. That's exactly what we want from this GRU. So it learned the body of text. It's pretty small in this case. Of course, this is just somewhat of a silly example. I'm trying to illustrate the point, but in real life, you would feed in a huge corpus of text here. It could be several volumes of books. It could be encyclopedias, Britannicas, whatever you want. This is essentially how, what's the thing called? ChatGPT learns. It learns how to make predictions of what word should come next based on historical examples that's seen in the past, right? So essentially doing like a mini ChatGPT right here. So I think that's pretty cool. Again, I'm going to copy and paste all this code and then save it in an HTML file. And then you can go ahead and run this code on your Jupyter notebook whenever you have some free time, and then explore all the details of what's going on. Okay, so you want to be able to run the code, peel back the layers of complexity, figure out what's going on under the hood here and make sense of it, and then apply it to solving your own problems, right? Your situation is going to be different from my situation, but once you understand the concept, you can plug in any data you want, run it, and you're going to get the results that you're looking for, right? So this is a slightly different type of neural net. This is a generative adversarial network. So this is used to generate new data that's similar to the existing data, but that new data doesn't necessarily exist. So this could be image enhancement, image distortion, image transposition. It works great on pictures, right? But on other things too. It'll generate data for us. So brand new data that has never existed before based on historical data that's already been trained on and observed and been tested and been able to make predictions. Data augmentation, style transfer, anomaly detection. You'll see in some of my other videos, there's many ways to do anomaly detection, typically with isolation forest or with clustering. There's a bunch of clustering techniques. Domain adaptation, right? So there's so many applications for this type of GAN, right? So we are going to look at image. Oh, here's one more application, image to image translation. So you can translate one image into a brand new image. The example we're going to look at here is more like data generation. So we're going to generate brand new data from existing data, but this data that it's going to generate has never existed before. Okay, so we're going to hit Control Enter to run this. And I'll take you through. It basically goes into this folder that I have on my desktop. It trains on these images. So this is the classical machine learning set, right? You have X train, Y train, X test, Y test, right? So you split that into your training and your testing components, right? And then once the model is trained, you compare it to the test data set and compare the predictions to that data set and then the actual test data set and see how close or how consistent or disparate that is. Okay, so we did epochs, batch size. An epoch is basically a loop. So one epoch is one loop. We have to loop through the data, in this case 100 times. If it's not performing sufficiently, you can certainly increase this number to 1,000, 10,000, whatever the case may be. Of course, it's going to run slower if it has to do 10,000 loops. But if we can get good results with only 100, then I think that's sufficient. So let me scroll down and see what this thing came up with. 7, 8, 9, 10, and a number 1. And let me go to the folder where this data sits. Okay, and this is exactly what we see over here. 7, 8, 9, 10, 11, 1. It looks like in this case it made the numbers a little bit fuzzier, right? And add some distortion, a little contrast to that. And it's fine, right? It's doing exactly what we told it to do. There's many different applications for these neural nets. So I would invite you to take a look at that and explore it, and just try to understand it better. I think the payoff is huge when you understand how these things work. And again, so many applications for this. These are just 2 simple examples. I want to keep it pretty straightforward and pretty generic so you can copy and paste the code, see how it works on your machine, and then start to think about use cases for this type of thing, right? These models are very powerful. The sky's the limit. You can do whatever you want. The only limitation is really your own imagination. That's it. So thanks for your time today. Hopefully you learned something new, and have a great day.